Alright guys, so today we're going to talk about kinematics again, and in the last video we also talked about kinematics, but we really stuck to simple problems. Most of the problems had the same start height as the end height, so we started from the ground and the projectile landed on the ground. And today we're going to get a little bit more complex. We're going to have a different start height from the end height. And although it's a little bit more complex, we're really just using the same four equations as always for kinematics. We might just tweak them, not tweak the equations, but tweak our way of solving the problems just a little bit. So let's start off with the example of throwing a projectile exactly upwards at 90 degrees. So let's imagine that we are on a cliff of 70.0 meters high, and we throw a rock, for example, at v initial equals 12.0 meters per second. And the rock goes up, it reaches its max height, and it comes all the way back down to the ground. And this will be our y final, this will be our y initial. So the question asks you to find the maximum height. It also asks you to find the total time for the rock to go up to the max height and back all the way down to the ground, which is 70 meters below the cliff. See, that's the difference in this problem. And finally, it wants us to find the final velocity of when the rock just hits the ground. Alright, so when we're dealing with this type of problem where we're throwing it straight up and it's coming back down to the ground, a very useful thing is to find the final velocity first. This is because with the current variables that we have of only the initial velocity and the height, the only equation that we could find time with is this one. And of course we'd use y equals y naught instead of x, since we're speaking in the y direction. But with this equation, we would have to use the quadratic equation, or the quadratic formula, since we have a t squared and a t here. We'd have to use negative b plus or minus blah 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 blah. We don't want to use that because that is time consuming and we want to safeguard our time. So what we can do instead is find the final velocity by using this equation here. Final velocity squared equals initial velocity squared plus 2ay, 2gy, and then plug that into this equation here. V final equals v initial plus acceleration times time. So to find final velocity, we have to make sure we have some key concepts in our head. So we know that from the last video, as I explained, that the time for the projectile to move from its start point to the max height back down to its initial starting height is equivalent. This side of the parabola and this side of the parabola are equivalent. We're assuming it's perfect. Not only is the time t1, as I'll call it, on the left side of the parabola, we're not including this part. This is for later. The time to go from here back down to here at the same height that it started to, not only is it equivalent, but also the initial velocity at this point going upwards is equivalent to the initial velocity. Since it's moving downwards, we have a negative. It's not only, it's also equivalent, the initial velocity moving up and down at the same points, because we're saying that the acceleration due to gravity is equivalent and it acts over the same period of time. So now with that in mind, we can find the final velocity. We know that final velocity squared is equal to initial velocity squared plus 2gy, since now we are in the y components and the acceleration in the y direction is the gravitational constant. We have final velocity is equal to the root of v naught squared plus 2gy, and g in this case will be positive since gravity is working in the same direction as the velocity is pointing to. So now we plug in our calculators. We have v naught 12.0 squared plus 2 times 9.80 times 70. We take a square root. We should get a final velocity of 38.936 meters per second. And for the answer, we'd only have 3 sig figs, but I'm going to keep these extra digits. So to recap what we just did, we knew that the initial velocity moving upwards at the same height is going to be equal to the velocity moving downwards, and we are able to use that into our next equation of vf squared equals v naught squared plus 2a or 2gy. G is positive since it's moving in the same direction of the velocity, so the acceleration is an acceleration, not a deceleration. That's why it's positive. So now that we have our final velocity, we can find the time to move from this point here to the end point right here. So what we can do is v final is equal to v initial plus gt, since we're substituting a with g, since again we're in the y direction, there's a y acceleration from gravity. So we have our final velocity of 38.936 meters per second. Subtract over the v initial, which is 12.0 meters per second. We divide by that by g of 9.80 seconds, and that should equal t3, since we're looking at this section right here. So t3 is going to be equal to 2.7486 seconds. And remark how I added extra digits, since that's not our answer. This is only part of the time. We want to find the total time for the rock to go up here, back down, and then plus t3. So now to find t1 and t2, it's going to be very simple. We again use the same equation, vf equals v naught plus gt, and our final velocity in this case will be 0. So 0 equals v naught, which is 12.0 meters per second, plus gt. We get t is equal to negative 12.0 meters per second over negative 9.80, since in this case it's moving against the velocity. It's decelerating the object, or decelerating the rock. And we get t1 equals 1.2244 seconds. And since we said t1 is equal to t2, we can just multiply that by 2. 2.4489 seconds, and this represents the time for the rock to go up, back to the same height, and now we have to add our t3 from over here, the 2.74, we add it to our t1 plus t2 to get our total flight time, which should get 5.20 seconds with 3 significant figures. Okay, now that we have total flight time, we have the final velocity. Now all we have to find is the maximum height. And what we can do here is use this equation right here. Or actually, let's use this equation, much more simpler, since we don't have to use the time. So we have final velocity 0 again is equal to v initial of 12.0 meters per second squared plus 2gy, and we get 144 divided by, again, negative 144 meters per second, since I moved it over, and since gravity is acting against velocity again, we get negative 2 times 9.80, since I divide that over, is equal to y. Our maximum height should be equal to 7.35 meters. But careful, this is the height above our initial start. And since we labeled our initial start height as 70 meters, we have to add 70 meters since our reference is from the ground. We want to find the maximum height, and the maximum height is from the ground. So we have to add 70 from to this number that we just got here. So we just get max height equals 77.35 meters, and we want 3 sig figs actually, so we get 77.4 meters, and there we have it. We have solved height, total time, and final velocity. Alright guys, so this is going to be the last problem that we do for kinematics. It's going to be the hardest problem that you can ever encounter. We're going to tackle a lot of things with this problem, but if you can do this problem, you can do any of the problems you encounter in kinematics, so brace yourselves. And I also changed my shirt because I was speaking so vehemently that I was like sweating profusely, but anyways, that's not important. So let's start off with another cliff. Now let's say this time that the height is equal to 125 meters. And let's say that there is some object, let's say a car, with an angle of 37.0 degrees, and it's moving at an initial velocity of 65.0 meters per second. So we want to find the maximum height. We want to find time, and we want to also find the final velocity. Alright, so for this problem, there is the first thing that we have to do is change the velocity into both the x and y components. Since we're going to be dealing with a lot of x and y components, you might as well change them right now the first thing you do so you don't forget, because if you forget, you're going to get all your answers incorrect. So we're going to convert our 65.0 meters per second to x component. So we do that by multiplying our 65.0 meters per second by cosine of theta, which is 37.0 degrees. Likewise, we do that with the same initial velocity, but with sine 37.0 for the y component. And if you don't understand why I'm dividing the velocity into x and y components, you should check the first kinematics video that I made where I explained that pretty in depth. So if you do understand what I'm talking about, stay with us. If you don't, then go back to the other video. So we get, by plugging into our calculator, in the x direction, our initial velocity is 51.91 meters per second. 911, you want to add on some extra sig figs. And we also have in our y direction an initial velocity of 39.18 meters per second. Alright, now that we've divided our velocity into the x and y components, we can start solving. So the first thing we want to solve is the maximum height, because generally that's the easiest thing to solve. So we can use the equation vf squared, and notice I don't have them written down. You should have them memorized like the back of your hand by now. Is equal to v naught squared plus 2a x. So in this certain scenario, since we're finding height, which is always a distance in the y, we will be using everything in terms of y. So our final velocity at the maximum height we know as 0. Our initial velocity is going to be equal to 39.18 meters per second squared plus 2g. Since we're speaking in terms of y, we're going to have acceleration in terms of y, which is g, y. So then we get our y, which is our height, is equal to, subtract that over, negative 39.18 squared over negative, or 2 times negative 9.80 meters per second squared. Remembering that since the force of gravity is acting opposite the y component of velocity, in this case going from this point to this point, is going to be negative since it's a deceleration. It's decelerating as it's going from 39.18 meters per second to 0 meters per second. So we get a y of 78.1 meters, but we're not done yet with the max height, since we already started from a point which is 125 meters above the ground. We have to add 125 to that 78.1 meters. So our true maximum height is going to be equal to 203 meters. Alright, so we found maximum height. So the next thing we want to find is the final velocity. And in this case, the final velocity is going to be a little bit complex to find. Since in the last example, we were going straight up and straight down. The angle was, there was really no angle that the velocity was hitting the ground. It was hitting it straight down. In this case, we're at some sort of a slant. So there's going to be some angle between 0 and 90 degrees, depending on the y and x components, as we'll see. So I'm going to erase this because we're going to need some space in order to figure out the final velocity. Alright, so remembering from the last video, I was saying that from this point to the equivalent height point over here, from this parabola only, not excluding this, the initial velocity over here from the start is equal to the initial velocity at the same point, at the same height. So knowing that, we know our initial y velocity is going to be equivalent, so it's going to also be 39.18 meters per second over here. So in order to find the final velocity, what we can do is use the equation final velocity squared is equal to initial velocity squared plus 2gy, since we're in the y direction. And the reason why we chose y velocity to begin with is because we have y height and we're using the y height, so we have to have velocity in the y value, or the y component. So our final velocity in the y component is going to be equal to the root of the initial y squared plus 2gy, rewritten as root, right over here, 39.18 squared plus 2 times 9.80 times our height of 125 meters, which is over here. And we get a final velocity in the y equal to square root it, don't forget that, 63.13 meters per second. And this is in the y component. And remark that the g component, the g gravitational constant, is positive, since over here, although over here it was negative, over here we're moving in a negative direction, the y component. So the acceleration is in the same direction as the velocity, so the projectile is actually accelerating, so we should have a positive, don't put a negative. You always have to think of, is acceleration in the same direction, or is acceleration in the opposite direction? And that'll tell you whether it's accelerating or decelerating. And also use common sense. If it's moving upwards and it stops at a maximum height, you know it's decelerating, and vice versa. So once we have the final y component, we still don't have the final velocity, because the final velocity includes both components. So we do know, however, that the final x velocity is equal to 51.911 meters per second. And why is that? Because remember from the last video, there is no acceleration in the x direction. The only acceleration, or the only force acting on the object, since we're ignoring air friction, is a force of gravity. And the force of gravity acts downwards in the y direction. The x velocity stays constant, there's zero acceleration. So our final velocity in the x direction is equal to our initial velocity in the x direction. So now how do we find our final velocity? Well, think of a triangle. We can have a right triangle right here. We have A, B, and C. We know that by Pythagorean's theorem that c squared is equal to a squared plus b squared. That's just common knowledge. So c is equal to root a squared plus b squared. Right? Well, vectors act the same way. We have an x and y component. In this case, a, which is the y component, is 63.13 meters per second. In the x direction, or b, it would be 51.911 meters per second. And then we have the vector we want to find, which is the final velocity, which would be c. So you guessed it, we're going to use Pythagorean's theorem in order to find the final velocity, taking into account the two different vectors. So our final velocity squared is going to be equal to our y component squared plus our x component squared. So our final velocity is going to be equal to the root of our final velocity in the y squared plus our final velocity in the x squared. And then plugging in those numbers, we should get 63.13 squared plus 911 squared. Square root that, we get 81.7 meters per second. But we're not done yet. Remember, velocity not only has speed, but it also takes into account direction. And in this case, we're not going straight down, so we can't just add a negative to it. And it's not going straight up, so it's not just positive. It's at some sort of angle between 0 and 90 degrees. And now we're going to find out how to solve that angle. Likewise, we're going to use the example of the triangle again. So I'm going to erase this real quick. Whenever we have a triangle in trigonometry, also we're going to label it A, B, C, we have an angle right here. And the way we find the angle, we can use trigonometric functions. And we know tangent theta, in this case, is going to be equal to B over A. The way we find theta is by taking the tan inverse. Right? So we're going to do exactly the same thing, but with our velocities in the x and the y direction. So we're going to have, in this one, we're going to have again our 63.13 meters per second. Over here we're going to have our 51.911 meters per second. And we have our theta over here. So tangent of theta is TOA, we know, opposite over adjacent, is going to be equal to 51.911 divided by 63.13. We take the tan inverse of both sides to find our theta. And I'm going to just not write out the numbers, they're right here. And we'll get a theta equal to second tan inverse over 51.911 divided by 63.13. We get 39.43. But we're still not done, because this is the angle. Look at here. Here, I'm going to redraw. Let's going to redraw right here. The point at which the final velocity hits the ground. Here's our final velocity vector. That is not under the horizontal. What we want to find is the angle that is under or below the horizontal. In kinematics, it's always going to be below the horizontal. So we found this angle right here. We want to find an angle right here. And it's really easy. These are complements, meaning that they add up to 180, or they add up to 90 degrees. Complements add up to 90 degrees. So what we can do is subtract 90 by our theta that we found here to find the angle under the horizontal or below the horizontal for the final velocity. So you just take 90 minus 39.43, we get 50.6 degrees. So now our final answer for our final velocity is going to be equal to 81.7 meters per second at 50.6 degrees below the horizontal. You have to specify whether it's above or below the horizontal, because if you don't specify, we don't know if it's above or below the horizontal. Likewise, you can either put below the horizontal, above the horizontal, or if you put a negative, that means below the horizontal. You can't put both. So if you specify by putting a negative, that works as well. And for above the horizontal, you can just leave it positive. And that is how we found our final velocity. To solve time, basically what we do is do what we did in the last problem, but we just use the y component of the velocity. We'd find the time to reach the height, multiply that by 2 to find the total time from here to here, and then we would use our initial velocity, which is equal to the initial velocity over here, to find the time to hit the ground and add them all up, right? And yeah, that's it. And what we did was, remember, convert or find the x and y components of the initial velocity. Whenever we're working with y terms, use y components for everything. Whenever we're in terms of x, we use x components for everything. And don't forget, the x velocity stays constant since there's no acceleration in the x direction. Y velocity, on the other hand, changes. And don't forget your trigonometric trigonometry, basically. You're going to use some trigonometry, and don't just find the angle of the triangle, find the angle below the horizontal or above the horizontal and specify. If you can do that, you can do any of the problems, and good luck.